Today we already had like a great presentation about solution that you can build on top of Monday, and in our platform there's like thousands, tens of thousands similar solutions used by hundreds or even thousands users. Like each solution is used by that many users. And to make sure that the platform can support and support all of them and incorporate multiple solutions and withstand the traffic, we have like multiple different approaches to handle them and like protect the platform. I will just present one of them. But before I go to that, I will tell a little bit about the environment that we are in. So like the Monday.com is a platform that is used by around 250,000 companies all around the world. So there are users in Canada, United States, Brazil, Spain, all the way to Japan and Australia. And in many companies, these solutions serve as a core system of the organization, so all processes, all workflows are incorporated into Monday. And for some companies that have offices spread across all around the world, that means that those solutions will be used by like 24 hours a day. And the platform, clicker doesn't work. and the platform is fully customizable. So you can create like boards with many columns, with many column types. You can put like thousands of rows in data there. On top of that, you can add like multiple automations that run whenever you change any information in those items. And if that isn't enough, you can also build a dashboards that utilize all the data and visualize it. And you can even present the data like from multiple different sources. And all of that on the platform that is designed as a multi-tenant application. And because of that, like our platform, like many SaaS companies, we are prone to the problem called noisy neighbors. But what exactly the noisy neighbors are? And so that's the situation where we have the resources that in given region or like in given application are used by many customers. So there is no isolation. So like in that situation, actions of one customer can affect how the system works for other customers. And that doesn't mean always that the actions that those users are performing is some malicious action, like DOS attack or whatever. It can be a situation that they're just using the functionality normally, but the amount of data they have or the data structure that is there causing just a higher traffic. And if many users at the same time will use platform like that, it may generate problem for others. And there are some like ways to solve that problem. I would say rather mitigate. So for example, we have like more resources allocated, or maybe more smart approach to just try to scale out and add some resources. But at some point, we cannot like, scale out further because of the hardware limitation. Maybe the cost is the problem. We don't want to pay more for something that just isn't like viable for our company. So one way or another, we'll hit some limit that will cause us that we won't be able to support all those customers. And to solve the problem like that, we created a project IronGate to handle the noisy neighbors problem. And when we were designing the service, we thought about it as a last line of defense that will only like serve services with all other mechanisms will fail, and only then will intervene. But why I'm talking to you about IronGate, or why I want to talk to you about IronGate, because I didn't say that much. So my name is Łukasz, and I'm engineering technical lead in Product Foundation Group. And for past 2 years, I was creating IronGate and making sure that we can handle the traffic that we are encountering in our platform. But let's go into like details what the IronGate is. So first of all, it's a generic tool that allows us to monitor and block traffic if it's necessary. So we want to be able to use it in any place and don't have to worry like how it will be used and how to fetch the data or access the data. At least that shouldn't be like a problem for someone using it, because we need to handle it to make it possible. And like we cannot like handle all use cases that we're having. So we also want to have like a way to be able to manually perform some additional actions, like blocking users. And we want to be able to do that in some unified way. And that's what we provide. So whatever service is using it, from the perspective of someone managing it, it will look the same. And we want to monitor like different vectors in the system. So for example, we want to check how many HTTP requests are executed in the service, or how many database queries are there, or how many messages through queue is processed. And all those vectors, as I said, we want to make sure that the owners of the services won't have to bother how to access the data, and we want to know that we'll be able to get the unified data. For example, how many rows were returned by database call, or what is the path of the HTTP request, and so on. And what was also important for us, that whatever we are doing, we need to act reasonably fast. Because the situation where we are starting blocking users 30 minutes after some incidents happen just doesn't make that much sense. And a point that we also had in mind was that whenever we are integrated to services and there is some problem, we don't have to have an impact on those services. So in case IronGate is down, like other services, we don't want it to affect the services that implemented in the IronGate. Because in that case, we would just become the noisy neighbor that we want to prevent from. And to design that, we created an architecture of multiple components. So let's go through that system and all the components. And I will start with IronGate agents that we implemented inside the Monday services that are using us. But what they are. So we decided to create the logic of those agents as using the native technologies of those services. So in our case, it's mostly Ruby for legacy solutions or TypeScript for newer services. And it's kind of a trade-off because of that, we need to have multiple implementation to handle it, but it also provides some benefits. First of all, it's faster solution. Also, we can specify how we access the data, as I said, database access, or how we are sending the events to some queue for further processing, and so on. If we go with some alternative, for example, some sidecar, maybe we'd have one code base, but then we had to handle the communication, add some additional containers in pods, and so on. So we decided that in our use case, it just makes more sense, even if it adds some additional work for us. And as I said, that if we have any problems in IronGate, we want to make sure that those problems won't affect other services. So in worst case, we decided that if the service is down, we will, for example, use the data that is cached. So maybe we want the newest configuration, but it's still okay that we have some information we can operate. Or if you cannot send events to queue, we'll start queuing them internally, but also we'll start dropping the oldest one if we reach some limit, just to not have the out-of-memory exception, and again, don't cause the problems in the system. And another thing that we care about was that we wanted to have the minimal latency on the services. Because some services operate on tens of milliseconds per request. The response time is tens of milliseconds. And if we would add even more latency, it wouldn't make much sense. And to address those problems, we decided to implement all those logic that we are doing, like fetching the configuration, fetching the logs, or sending the events to queue as an asynchronous processes, like a background workers. And thanks to that, we're able to kind of separate it from the main application. And doing that, we managed to solve the first problem. So if there is any problem, it's just invisible for the service that it doesn't work. And the added latency was around 1 millisecond, so it's accessible in most cases. I already mentioned that when we get some information about the traffic, we send them to queue. In our case, we use Kafka for that purpose. we use the Kafka because Kafka gives us the possibility to have high throughput, but we also made some changes there. Like we decreased the number of in-sync replicas to 2. We increased the number of I/O and network threads. So we made all changes to even increase the throughput as much as we can. And it generates some problems because in that situation, in that setup, in some edge cases, we might start losing the events. But we decided that it's okay for us because we are trying to investigate the noisy neighbors. So we are talking about a situation where we're getting hundreds or thousands of events. So if I drop 1 or 2, it's fine. And it was the trade-off that thanks to that, we have just much higher throughput and we can process more information. And that's quite important for us because we are processing daily tens of billions messages just to be able to protect the platform. And after those messages are received, we send them for further processing. And what exactly is the event processing? And it's built of a couple of components. So first one is called event processing. And this flow, when we were designing, we were thinking about the possibility to easily modify how the events are processed. So we have a situation that there's different services, different use cases, and you wanted to be sure that all of them can configure the the flow, how it should work, in the way that it suits their needs. Also, what we care was something that I already mentioned in other part of the system, that we're optimizing that for speed. So we wanted to get the response reasonably fast. And to handle that, we decided to go with the solution called Apache Spark. And more precise in our case, it was AWS EMR cluster. And that is a distributed computing system that is optimized for processing large data sets. And it's also quite easy to scale if it's needed. Yeah, but how we address other elements? So to be able to easily configure our platform, we created something that we call rules, Iron Gate rules. And it's just a set of informations about how we want to process the events that we receive. We decide how we want to filter them, how we want to aggregate them, and which values are important for us for understanding that traffic is exceeding limits. And we enable them, and we allow to modify them through the internal portal called Sphera in our company. So every developer can go there, they can modify those limits, they can modify those rules, and just make it work for their needs, as it should work for what they need. And the idea was that, it should be that easy that those developers won't have problem to modify it. It requires a couple iterations, but I think that right now we reached the point where they are able to do it quite easily without asking us for the assistance. And also what I said that we wanted to give the flexibility in that tool. As we don't know all those use cases people will be using, so we allow them to specify all parameters that are needed. And when the rules are created, we decide that we'll be storing them in S3 and then fetching from Spark, because that way we just have another layer of separation. It was just easier to do that this way. But when we have those rules, it's read by Spark and it starts processing them. And what we have here, we have the processing pipeline that does multiple things. First, using the specified attributes for filtering, it's try to determine which events it's interested in. So for example, it can be a case that, okay, I want to only services created from my microservice, or I only want to have the events for SQL queries. And after we filter the items that we need, we start to aggregate them. So for example, okay, so aggregate them based on the account ID, or the user ID, or specific endpoint, because that's what I want to monitor. And at the end, we decide to aggregate them and produce some observations based on that. And we can aggregate based on multiple parameters and get the multiple output values. But at the end, we care only about one that we call the primary reducer value. And that one will be used to determine if the threshold was exceeded or not. And to be able to handle that much data, we also use something to be able to like determine if the limits were exceeded. That is called like the processing windows, because it's hard to answer like if million requests is a problematic transfer if we don't know the time frame. So for example, like million events, like million requests in 24 hours is probably fine. But if it's happened in 1 minute, it's most likely not. But it depends. It depends on the use case. So so in that situation, that span cannot be too short, because then any spike will be considered to be a problematic transfer, and that might not be the case. And it can also be too long, because if we have very long time span, we also have higher limits, and we might just miss some spikes that we'd like to catch. And like in our case, we discovered that the sweet spot is like between 60 and 120 seconds, and we can like catch the most problems that we encounter. And also to like further optimize how much data we're processing, we are using something what Spark provides, and it's called sliding window. Because if you have like 1 or 2 minute time span, that means that we can process like a lot of events. And in that case, Spark gives us something something that is called like micro batches, and it means that it processes events like in some groups, so it's just more efficient. So it doesn't process one event after another; it just takes small group and processes them all together. And in that situation, like in our use case, we have like a span of 1 second, and we are just moving that window. So we like drop all events that happened like at the beginning of the frame, and then we add all new events at the end. And after that happened, we like calculate what is the limit once again. So that way we only have to process like 2 seconds of data instead of like 120. And at the end, to optimize it further, we decided that we don't wait until the whole window is collected. If we will reach the threshold much sooner, we'll just output as an observation to start processing it right away and take some actions. And if that happened, we generate something that we call observations, and we store that in our database. And after it's stored in database, it will be fetched by, let's say, observation processing. And that's like another flow that will continue the analysis and take actions. But what the observation processing is, and also why do we have like 2 separate processing services in our architecture? So we decided to like separate the event aggregation from like observation processing, because those serve like 2 different purposes. The event processing is all about speed. It has to like aggregate and create observation as fast as possible. And also, we don't generate observations that often, especially observation that exceeds some specific limits. And on the other hand, the observation processing is responsible for like communication with some other services. So it's just must take more actions than the first one. So we thought that we don't want to slow down the event processing just to be able to do everything in one place. But let's go into details of the observation processing. So first of all, we have like 2 input points there. First, we get the observation that was created by event processing, and also we get the rules that were defined by developers. And inside those rules, developers could specify like which action should be taken if specific limits were like exceeded. And those actions can be like creating items in Monday.com boards. Maybe they want to create like PagerDuty alerts. Maybe there's like limit exceeded that we want to create some log in our database that can be shared with the services, and many, many others. And it's up to developers to decide how they use it, because once again, we don't know their domains, and it's like doesn't make sense to like treat them all the same way. And also we allow to like specify different thresholds for those actions. So for example, if there's like some threshold exceeded that isn't that problematic, maybe we just want to get a notification through Slack that, okay, we'll handle that later. If that's something that we need to look into right away, maybe want to notify some developer on call. And in the most severe cases, maybe you want to block the traffic and therefore like start blocking some users automatically, and we can also specify that. So after the observation was processed, and we decided that, yeah, some logs should be created, we'll store that information in the database. And after it was created in the database, it can be then read by something that we call IronGate service, and it's like a back office for all those integrated services using IronGate agent. So they can then fetch like the data from that microservice and start like blocking the users, blocking the traffic based on what was specified in rules and how the blocks were defined. And for that process to make sense, we decided that it shouldn't take more than like 60 seconds from sending event to like starting blocking the traffic. But 60 seconds doesn't sound like a very demanding limitation. And the question is if it could be lower. And the answer is yes, but like always, it's always a question of trade-offs. So to make it much smaller, probably would require like changes in the architecture, maybe having like more resources and so on. But we observed that like our platform can withstand like traffic for some time. So like 60 seconds doesn't cause a problem. So we just optimize it that way. If we needed to make it faster, we'll just look into that. But for now, it works. But also, we have like that mechanism of blocking. But we also, when we are building that we observe that IronGate like collect a lot of data, and the data that can be used in other purposes. So we started thinking that, okay, maybe instead of focusing only on being like the last line of defense, we could start to utilize that data to use like much sooner. So we were thinking about, yeah, maybe let's build something like the first line of defense. So like we saw the use cases where we are blocking the traffic, but if, for example, we provide some data to the developers and they specify like more precise limits or change their logic a little bit, those logs could be prevented and we wouldn't have to like create them in the first place. So we decided to create like another project that is called IronGate Insight. And it's like a complementary solution to the first one, to the locking mechanism. So you already saw the flow regarding the like generating the observations and then generating the logs. And that one is like optimized for speed of the observation generation. But we also have like another flow, just like focus on collecting the events and archiving them in our case in S3. But this flow has a little bit different like priorities. So it might work much slower. It might take like minutes or even hours to process the data. But what we care about is what is the output. So we want to create the Parquet files that are optimized for future reads. So whenever we decide to fetch some data, it should happen fast. And also those changes, like adding like the new processing flow, being able to like output it to S3 and query through Athena, caused that we had to make some changes in our approach to like event sending. Because we were using initially JSONs without any enforced schema, and because of that, like we had that problem that wasn't that huge issue before when we didn't allow users to like query any data. That, for example, right now without enforced schema, we could have a situation that someone sent us the request duration as 30 milliseconds, and in another event it was a doc, and it just doesn't make sense to like aggregate those informations. So we introduced protobuf instead of JSON with enforced schema. So thanks to that, we had like a guarantee structure of the informations, and also it reduced the size of the events by like 40%, what also gave us some headroom for future expansion, which was pretty nice. Yeah, and at the end, like with those changes, we had like two sources of data. One was the database with logs and observations. Another was like events in S3 that were creating through Athena. So we decided that, yeah, maybe it works, but it's a bit cumbersome. So we like try to like integrate that and provide like the pretty nice user interface on top of that. So we decided to use a superset, Apache superset, to like be able to read from those sources and display the data. Just not have to build that from scratch, because yeah, maybe it's cool, but it probably would take a lot of time and it wouldn't look nice, especially if I was developing that, but whatever. So yeah, so we have that single place to access all those data. And also, like, it's pretty easy to use because it's like kind of standardized solution. So like that separate instance allows like other developers to like easily use the flows that we define, the charts, the dashboards, but also if they need, they can like modify them and create like their own. And it's also is pretty like it's Apache, so like reasonably easy, not super easy. Okay. Yeah, and all that sums up what the current setup of IronGate is. But there's a question: was that effort that we were doing for like past 2 years was worth it? And probably the best metric for success is to like how many incidents we managed to prevent, like using our solution. And there's no easy answer to that. Because we are trying kind of like predict the future that never happened. Because what would happen if we wouldn't block the user and the traffic would drop? And what would happen if at the same time those users would start generating more traffic, or the service wouldn't scale out in the time? Like there's like many factors that we just cannot like figure out because we don't have the crystal ball to do that. But I will share with you like 2 numbers. So in the last year, we had like situations, like 17 situations, where log caused some code changes in one or multiple services. So we could like clearly say that in that case, if the IronGate didn't intervene, it would in the long run like result in some incident. It could be like a platform, like the performance degradation, or even the platform downtime. But the situation isn't always that clear. So on the other hand, we have the situations that IronGate intervened like 3,600 times, also in the same year. So question, how many incidents we really prevented? I have no idea. It's some value between those two. And yeah, that's the question that managers are asking us over and over, and yeah, we cannot really answer them correctly. Yeah, but I would say that what was the most important for us was the change like in the mentality of people in the company. Because IronGate showed that just showed that we should always care about traffic and try to like understand what is happening in our system, and to just act before the problem, like observe, like what we are observing will become the real problem. And IronGate just provide like the tooling to do that. We can block some users, we can provide and give you like more information. But at the end, it's like in the hands of others to take actions and like fix their services. Because I said, we just create tool, we don't know their logic. And that's how IronGate is organized, and that's how it helps to protect our platform. So if you have any questions, I'm more happy than, I'm very happy to answer. Yeah, I see I have to. So first question is, do you notify users that they generate unusual or too much traffic at the time, maybe in advance before blocking, like a warning? So in many cases, what we are like detecting, it might not be a situation that user as people using the Monday will know about it, because it'd be like an automation running in the background or any other process. So we just like cannot give them that warning. It's like more internal information for other developers to take actions. So we notify developers. We have like lower limits to let them know that something is happening, or we're just reaching to them like proactively to make some changes. But users will in most cases just get 429 error, and that's what they get at the end. But the limits are very generous, I would say. So we are really like catching small fraction of those situations where there is some problem. So it's really like in some exceptional traffic. I don't know if that answered the question.
Yes.
Thanks. And there is another question. Do you compare weight of user actions and events, meaning that some actions can be much more resource heavy than others? And regarding that one, I would say we don't really have like the real measurement, that automatic measurement. So we more rely on that, and that people specifying the rules, they will know how heavy their actions are, and they will just specify separate limits. Probably we could look into that, but again, even if we had some mechanisms like that, at the end, it will still be like a developer that would have to decide that, yeah, even though we detected something, it makes sense in our services, because in some places we like heard that, yeah, cool that you could block that user, but we just prefer to scale out and just support it. Because in our use case, like being able to like create much more resources and process data faster is just a use case that we want to follow. So we don't have that solution, and as I said, we just rely on the configuration of the other developers. And there is like the third question, did you try to solve the problem on the client side? And I would say no, but it's also like, I don't really know what will be the solving on the client side, because in our case, I would say like the most cases isn't like the user is doing something bad, like he's trying to do some malicious actions. It might be the case that users are just having like a lot of data, and in their workflows, it will cause the problems. So what we are doing, we have like the CX people that are reaching to the customers if we notify them, and they will just try to like discuss them with that maybe the flows should be changed or they should be updated just to not cause the problems and not like cause us to block them. But we don't have like the direct information, like the feedback loop for the users, or like being able to solve that in the front end, because many cases it's just like an inter-service communication happening just somewhere in the background. Any other questions?
Unless you work for Monday, then they will come specifically to your desk.
Yeah, that's another problem.
You introduced like Iron Gate Insights, and the first thing I thought, it's a metric system. It's a system to produce metrics and absorb them. So right now, is it like a default solution to track some metrics?
No. So our default solution to track metrics is Datadog. But in our case, we wanted to focus on high cardinality data, because we are measuring like all accounts at like 250,000 different IDs, or even in some cases, we are just tracking the specific users. We are talking about millions of different metrics. And probably Datadog will be very happy to like be able to accept that and process, but I don't know if there is any company in the world that could like pay for that. So it's like we have like very narrow focus there, that you want to be able to like have those metrics about traffic, specifically about the high cardinality, focus on high cardinality and be able to like access it fast.
I have one. So while you're storing this data, I would say events, you're storing it in S3, as you've mentioned, or it was like one branch, I would say, to storing it in there. So my question
about the events archiving?
Yeah, I would say so.
Okay, so the question is that if we are storing them is S3, so...
Yeah, my question,
okay.
I would say some kind of postfix for this question about like why not storing in Snowflake. Did you like consider it because it might like with this kind of information and lots of events be valuable maybe in the future or like now? So maybe analyze this data with features of Snowflake, because we are doing kind of the same thing for our clients, I would say, but we are doing it internally.
Yeah, I think that there's similar solution in AWS to like analyze data. We're like investigating that, but like in the current state, as I said, like creating the Parquet files and just like querying them using the AWS Athena was sufficient. We've probably increased number of data. We can like consider other options.
Yes, I just didn't know what's Athena, so yeah.
Yeah, so Athena is like the query engine in AWS, and it can like query different data sources.
Okay. Thank you.
Okay. Okay, if we don't have more questions, so thank you.